Hi, I'm Jacqueline, and this is my red cabbage pH indicator lab report and documentation of the actual lab. So, first, some background knowledge. The pH or potential of hydrogen is a scale of 14 colors which are used to measure the acidity or basicity of certain solutions. In this spectrum, from red to purple, level 7, or kind of a green color, is neutral. So 1 to 6 are acids, starting from red, and 18 to 14 are bases, and that ends at like blue or purple. My research question was, how does the number of red cabbage leaves impact the pH and how the indicator will perform? My hypothesis is that if a greater amount of red cabbage leaves are added to the indicator solution, then the color of the pH level will be affected. Variables. The independent variable is the amount of cabbage used and the type of substance. This is because these are variables that you can change. I saw another student that separated the cabbage leaves into groups of 2, 4, and 6, and I thought that was a really good idea um, to see how the acids and bases react in the different consistencies, so I did the same. So the number of cabbage leaves change from the group of 2 to 4 to 6 leaves and are measured by each leaf. The type of substance changes because there are both acids and bases used, and these can change as well. And this is a change in the solution, and you're measuring by tablespoon. The dependent variable is the color of the solutions or just the pH levels. These factors are what is measured in this experiment. For controlled variables, first is the amount of water. The measurements of water were kept constant because they were to be mixed with different amounts of cabbage. This was to ensure the concentration of cabbage water was controlled and would not negatively affect the results. Next, the amount of base or acid used. Changing the amount of solution between water cups would affect the pH, therefore, it must be kept the same. Lastly, temperature and lighting. By making sure the experiment was performed under constant temperature and lighting conditions, it makes for a fair test. Now for the actual experiment or the method. First, you need your materials, so 1 head of cabbage, lemon juice, glasses for the cabbage water, strainer, tablespoon, knife, measuring cup, and a pot with a lid to boil in. So the first step is to cut your red cabbage into little pieces. So as I mentioned before, I got the idea to do the 2, 4, and 6. So I just did 2 leaves, 4 leaves, 6 leaves, and separated them into their own cup. The next step would be to boil each section of leaves, and all for the same amount of time. And I used a timer for this. And then once you see this nice purple color, then you separate the cabbage from the water. So here I put each section into their own cups, and then I labeled it, and you can see there's a nice gradient color from the different concentrations of the leaves. And then once I got this, I separated each of these cups further, and I did that so that I can see acids and bases in the lightest, middle, and darkest color. So I combined the acids with the bases, and the acid I used here was lemon juice. So you can see me adding it here. It turns into a really nice pink color, and that's because the pH number is going down, which means it's getting more acidic. And you can see there's a little cabbage piece in there, which I will address in the problem section at the end. But yeah, it's just getting more acidic. And then over here, I'm adding my base or my baking soda. And you can see that it's turning a lighter, more cloudy color. and that's because it's becoming more alkaline. The pH number is going up. So these are the results. You can see that we still have the gradient going from left to right, but we can also see it not just in the blue how it used to be, but we can see it in the acid color here and then the basis color here. So it's going from light to dark, and then light to dark. Here's a time lapse of me doing it, so that turned pink there. And then I'm adding my baking soda. It's turning a cloudy color. It kind of settles after a while, but you can see right as it's mixed, it becomes a lighter, more cloudy color from the original cabbage water. So here is a chart and table of my results, and you can see that this is the amount of leaves, and this is the pH level. And as the amount of leaves increases, the bases also increase, but the acids decrease. And then this table just reiterates that in more detail. So the 2 cabbage leaves had a light pink color, a light turquoise, and a cloudy blue. 4 cabbage leaves, it's kind of in the same thing, just a little bit darker. And then 6 cabbage leaves, medium pink goes to red pink, blue goes to dark blue, cloudy lighter blue goes to a cloudy dark blue. So just what we saw in the time-lapse video. Concluding reflections. I found that as the dependent variable declines, the independent variable escalates. This is seen as the number of cabbage leaves increased. The acidity also increased, while the acidity decreased. By reviewing the results of the investigation, I can conclude that the data supports my hypothesis. The number of red cabbage leaves did indeed affect the pH and shows the direct opposite relationship between acidity and basicity. So the problem. As I mentioned before, there were very, very small pieces of cabbage left in my solution, and this was because maybe like not proper straining, or also because the solution was very dark, so it kind of made it hard to see if there was even anything in there. But why is this problem significant? Although only a small amount, the cabbage scraps have the ability to continue to change the water color even after drained into the cup, especially if the water is still hot. And the solution to this is to just make sure to completely strain the water after boiling, and maybe check again for any stray pieces just to ensure that we're getting a clean solution. Here are my references, and that's it. Thank you.